We've been talking about unit vectors and the fact that unit vectors have a length of 1, but what happens if we want to make a vector in a certain direction that doesn't have a length of 1? Well, that's where this new formula is going to come in. First of all of these letters are bold, and so they're meant to have those little arrows over them, meaning that they're a vector. Also, you'll see that this has double bars on it. Normally, I've written magnitude as being just single bars like this. So something that you can see with the double bars, single bars, they just mean the same thing. But what we have here, if we're going to have any other vector, so meaning that it doesn't have the length of 1 like a unit vector has, then we're going to just take a unit vector and multiply it by a certain amount. So we need to know what that magnitude is going to be. We can choose whatever we want it to be. But if you remember from the last example, this right here is a unit vector. Since that's a unit vector, since that's got a length of 1, if we multiply it by whatever number we're talking about, we just multiply it by that and we have a vector of a new magnitude. So if I wanted to double this, if I wanted to make it a magnitude of 2, I just plug in a 2 for this first number. We'll see some examples coming up with that, but I just do also want to mention this linear combinations thing. You're going to maybe see this from time to time. It's got the i's and j's, but remember, it's not really that important to use this alternate version. I would stick with this, and I would ignore this for now. If a problem asks you to put it in terms of i's and j's, then that could just be the very last step that you do, and so it's really not that important to have that understanding here. We're just going to stick with this formula for the remainder of the examples.